All right, so we are in week 6, and week 6 talks about circular lists. And circular lists are very similar to that one first kind of a list that we had, except what you do is you don't really have a concept of a first, right? Instead, you're going to have a link which is called current, and that link can move around the chain of links, and just that's it. So the last link does not point to no, because there isn't really a last link or a first link. The last link points to the first link. Okay, so they're all linked together. Last one points back to the first one. If you insert any link in there, they still preserve the relationship. So there's that. And let's go through these things that I have for today. So this is...
I'm sorry.
Yep.
The last points to the...
First, to the first actual link.
There's no first, right?
Well...
Look just to the left of that.
Yeah, there isn't a first, but I guess that is the first. There isn't a specific variable first which points to the first link. So in the previous linked list that we had, you had a unique link which was called first,
right,
which was equal to this one. There isn't such thing in the linked in the circular list.
So when you start going through the loop, where does it start? There's nothing that notates.
It could start anywhere where current is.
Whatever current is.
Yeah. So now I guess the question that you might have is, how do you know to stop going through these links so you don't go in circles forever? Well, you would have something that counts how many links you have and count how many links you visited. So on top of everything else that we have, you should have something like number of links, right? And then maybe some kind of a count links. And as you go through the loop, every time you go, as you go through these links with a loop, every time you visit the link, count links goes up by plus, and so on, and so on, and so on. And then when count links becomes equal to the num links, you stop going through the loop. And that's pretty much all there is. So, let's go to look at LaFour. Where'd I got it? All right. And linked lists. Do I have a circular in there? Chapter 5. Well, these are the actual assignments. Circular queue. All right, let's close this. Okay, so we're not really talking about double. So this is your regular list. This is a double-ended list. We're not going to do this until next week. Efficiency of this, stack implementation. Okay, so what I'm going to do is, yeah, it's not in the book. No. So I'm going to go in there and just look through this stuff here that I have posted. I have some examples. Let's look at those. Yeah, okay, so the chapter talks about what abstract data types are. And again, the abstract data types is some kind of a real world problem that you're trying to simulate in your program. Like a line of people, that's the abstract data type, or a stack of plates, that's the abstract data type, or a bag, that's the abstract data type. And the actual implementation is the data structures. There's a data structure, we can do this one way in C++, there's another way to do it in Java, and so on and so on. The interface is basically just all the different methods that we're going to use to change the properties of our data structure. Okay. This chapter also talks about the efficiency, linked list efficiency. Insertion and deletion of linked lists is very fast. right? All you have to do is just change a couple of links, relink things, basically at 2 different steps maybe, if that, or maybe even 1 step if you have a deletion, right? You just point the current link to the one next, and then it's done. So it's pretty much a constant time. Doesn't matter how many links you have in the link list, it will always be a constant time for you to insert or delete a link. However, finding and deleting links is quite long. Okay, so you have to go through as many links as you have to in order for you to get to the one that you need. So if you have 1 million links, you got to go through 999,000 of them to get to the one you need. So it's not as efficient as if you had a array. With the array, you can just go directly to the position that you need. Okay. Another advantage is that when you have an array, you start an array of a certain size, assuming that maybe, we might need like 1 million things in this array, but maybe you only need 2. So why would you take up space for 1 million things in memory, especially if those 1 million things are not just simple integers, but you have huge objects that hold data, right? So for that reason, arrays are not practical. There's vectors. Right? There's another data structures in addition to arrays, and yes, arrays are data structures. Vectors are built into a lot of these programming languages. And what is a vector in Java and C++? Well, it's like an array that it expands itself in predictable manner. So let's say, for example, if I have a vector of 4, and I'm trying to add a 5th element, then it will tell itself, okay, I need to expand. So it'll go and double itself in size. So it'll go from 4 to 8. Okay, and that is the disadvantage, that this expanding is not always by how much you need, right? Maybe you have 16 and you try to add the 17th now, and it's going to think, okay, hold on, let me double myself in size, go up to 32. You don't need 32, you only need 17. So that doubling up in size in vectors is not very practical, even though they suit most of our needs. Linked lists are better because if you're going to insert an extra link, you just insert that extra link, and then it expands itself and it contracts itself by however much you need. And if there's anything just floating around in memory, the Java garbage collector goes through the thing and wipes out all the things that are not being used. So that's what this is talking about. Stacks and queues as array or linked lists. So you can implement a stack and a queue both as either an array or a linked list. Okay, and there's some example programs in this chapter. You can type them up, get them to work. You'll see how it works with how you can make a stack and a queue with a linked list. But what was a stack and a queue? Just we fixed how we can insert things into an array, right? You can either add at the front, remove from the ends, or some other predefined way to insert and delete links. All you have to do is restrict your linked list to only add links in one way and then remove links from another side, and then becomes a queue, right? If you have a stack, again, you can only add and remove from one side of the linked list. So the actual implementation of a data structure, you can see, is you can do multiple kinds of data structures for the same abstract data type. Right? Could be a linked list, could be an array, and for simplicity's sakes, a lot of the things that we do are going to be, we're going to start with arrays and then move on to something else from that. Okay, so I guess underneath it, I have a couple of links, circular lists, find, delete, insert. So what you have to do, let me just have a look at the assignment for today. Okay, so we know what it is. Make a class for a singular linked list that has no end in the beginning. The only access to the list is single reference. So that's just the regular. The reference can move around. Your list should handle insertion, searching, and deletion. You should also be able to display the list. A step method that moves through the list should do that. Okay, so you need to do a couple of these. So you need to do a search through this list. You need to do an insert after a certain value is found. So you can use these together, right? So let's say you have a linked list of however many things, there's a number 10 in it somewhere, right? You're going to look for that number 10. If you can find a number 10, this method should return true. And if you want to insert after that value, right? So this is insert after value found. You're inserting some new value, and you're going to insert it after a certain value. So first you have to find the value. You could use this one, right, to find the value. And then this one here is going to insert after it. Okay? Deleting, just the usual thing. So you kind of know how to delete thing. This time you have to do it with a circular list. You find if there's multiple values of the same exact values in the linked list, say you have 2 10s, you're going to delete the first one that you encounter. You can make it so it deletes all of them, but let's just focus on the first one. Okay? So the first link, which has a data that is matching to your value that you're looking for. Displaying the list, right? That should be kind of similar to this step thing that we had. So display the list. This is your hint for that. Count how many links you have visited and compare that to the number of links total that you have. And if your count becomes equal to the number of links minus 1, then you have gone through the entire circular list. Okay, there's another hint here. You might find it convenient if the delete operation takes place one link downstream of the link pointed to by current. Okay, because the upstream link is singular link, so you can't go. So current points to, let's say if current points to the one you're trying to delete and you're deleting that thing, you're kind of losing track of where you are. But if the current was pointing to the one before the one that you're trying to delete, all you have to tell current is equal to current.next, and you deleted the link. Okay, so that's the reason. You could of course have a current and then previous if you want to insert an extra link. That would be a way to do it, but I wouldn't recommend it. Okay, so now let's have a look at some of these things that I show in here. And there's my ugly pictures again. Sidebar. Okay. So the circular list, let's say we have some kind of a link list that looks like this, right? These are my different links, right? 6, 5, 4, 3, 2, 1. Current points to just one of them. Okay. Actually, current is equal to the link that you're looking for. Okay, I kind of mislabeled this here. Okay, and what is this thing supposed to do? This is the find. Okay, so all you have to do is this one, get home is equal to count. This is going to keep track of how many links you have visited, right? That's why, so basically count is going to be equal to how many links you have, right? You have 6 links. And what you're going to do is you're going to go through each of these links. You basically tell it current is equal to current.next. Okay? So again, my label here is incorrect. Current itself is equal to this link, right? So current.next is actually equal to link 5, not link 6. So when I say current is equal to current.next, I'm telling it, okay, basically you, which used to be equal to this, are now equal to this. And that's it. That's how you move down the circular list. Okay? Until you get to the end of the thing. And how do you know when you get to the end of the thing? Well, when get home is equal to 0. Okay? And then right here, this is my find basically. So get home equals count. Count is how many links you have. While get home is greater than 0, which means you haven't gone through all of them. If you find a matching link, right? If you find a link which has the data as equal to the key that you're passing into the method, you're going to return that link. And you're returning a link. You're not returning the data, right? So you're returning current.next. And if it isn't, right, if they're not equal, then you tell it and current is equal to current.next, move down the line, right? If this loop is done and you haven't found anything, this is not going to happen, so you're going to return no. So you haven't found anything if this method returns no. Okay? So that's basically finding something, going through the list. Okay? Any questions on this stuff? Yeah.
Would there be any benefit to sorting the circular list?
We're going to do that. We're not going to do the sorting right now, but we're going to do next week. We're going to have a double link, double-ended priority queue with the linked list. So if you have a sorted list, sorted linked list, that is basically kind of sort of like a priority queue. And what was a priority queue? Remember, queue where not always people that arrive all the way at the end, right? Some people are more important and they get to, cut the line, they get to maybe go all the way at the front, or they get to skip a couple of positions. So in other words, if you have numbers 1, 5, 10, and then number 3 arrives, we're going to put the 3 after the 1, not all the way at the end. So insert in order is something that we're going to do next week. But yeah.
What if you have just one link? It's a circular thing. Does it still work? You just point to yourself. Like there's only one.
Well, if you have one link, you would know that by count. Right? So count will be just 1, and I guess you could say if count is equal to 1, you don't need to do
And visually,
any.
does it just point back to itself?
You could do that.
Or
Yeah,
does it know, or-
but it's not needed. Yeah, you could. I guess you could see that. You could say that. So I would say link. Yeah, if you have a single link, then that link's next should be equal to itself. Yeah, that makes sense. Since we're not supposed to have a no,
Okay.
right? Question?
One more question, just to understand the circular linked list. When would it be beneficial to use a circular linked list rather than just a normal linked list?
As far as practical applications, honestly, I can't think of an actual example that you could benefit using this from another linked list. It's just more of an exercise for you to just get comfortable with lists so that you can reconnect them in different ways. I gotta think about that and come up with something. Yeah, I can't come up with anything off the top of my head right now. Yeah. But it's more of a just like for you to wrap your mind around how a linked list works so that you can realize, okay, it's not just this way, we can go through it in different ways. We don't need to have a first, we can just have a current, okay? So this is finding through a circular list. I also have deleting through a circular list. All right? So how does this work? Again, count keeps track of how many links I have. If there's nothing to delete, I guess temp link is equal to current, and if there's no links, then current itself is equal to no. Okay, so that's the default case. If you have one link, so that's right. If count is equal to 1, what you're going to say is, so temp link is the one that you're going to be deleting, right? So you're not only deleting the thing, you're returning it also, right? So you're getting the link that you're supposed to delete, you're making temp link equal to that, and then you're returning that thing. Okay? So if you have only one link, right, which is basically going to be equal to your current, you're going to return that. Temp link is equal to current, you're going to return that link. Then as soon as you do that, to indicate that there's no more links, current is equal to no. Okay? And as soon as that is true, then you do count minus minus. So now count is going to be equal to 0. And that's it. Okay? So if you ever try to delete a link after that, temp link is equal to current. Current was set equal to no if you don't have any links after you deleted the one link. And you would be returning a no again if you try to delete a second time. And this default here is basically if we don't have a 0 or a 1 link, then remember what you want to delete is delete the one that is 1 down from the current. Okay? And how are you going to do that? Temp link is equal to current next, and then current next is equal to the temp link next. Does that make sense? Okay. So if you have, let me see, I probably have some pictures in there. Hopefully it makes any sense. Where are all my links? Damn it. this is okay. So this was the case for one link, or for no links, right? This is the case for one link, and this is the case for multiple links. Okay. So let's say current is equal to, and again I have mislabeled this. So current in this particular case right here, current is equal to link 3, right? So let's suppose that I am trying to delete, I'm trying to delete link 3, right? Okay. So the first thing that I do is I say temp link is equal to current.next. Current.next, so current.next, the next of current is actually link 2. So even though I put link 3 here, that's not right. This is actually link, instead of link 3, this should be link 2. So when I say temp link is equal to current.next, I'm actually telling it temp link is going to be equal to, no, I guess it is that way. Yeah, it's link 3. So current temp is equal to current next, which is equal to this link. We're trying to delete that one. And then current next is equal to temp link next. So the temp link next, we're basically telling it to reconnect current with the link 1 down. Okay? Does that make sense?
It looks like it's telling it to connect to link 1. Current.next is temp link. What's temp link pointing to?
So temp link is equal to current.next. Current.next should point to the link down, 1 down. Not this link, but the one after. And then current.next is then equal to the temp link next. Because since you're deleting this one, you want your current to, the next of the current to be equal to the one after it. Okay? And again, this is one of those that it will make a whole lot of sense if you actually write it out on paper. Okay? I'm going to update this thing a little bit better, have this stuff rewritten. Okay? But all it is, you're telling it the current one, that the one that you're returning, the current stops at one link before the one that you're trying to delete. Okay? So that's, again, the current stops at 1 before the link that you're trying to delete. So temp link is equal to current.next. So temp link is equal to 1 link down from the current, which is what we're trying to delete. Okay? That's the first one. And then the current.next, so the current.next stays the same. I mean, the next for the current is equal to this next link next. Okay?
I'm going to have to reread before.
Yeah.
So in the end, where does temp link point and where does current?
Temp link is the one that you're deleting.
So that points to 3, link 3.
Yeah, and then the current.next points to the one down.
To link 2.
Yes. Yes. Well, actually, no. It actually, no. Current.next will be temp link next. So temp link. So we're trying to delete 2, or we're trying to delete 3. So that's what temp link is equal to, right? To the 3. So current.next is equal to temp link.next. So it's equal to 2. So the current points to the one down from the one you're trying to delete. Okay? Question? It will make sense if you write it out on paper. So I'm telling you for real, make sure you write these out. Just like I try to do this here, and I gotta fix my freaking, I put the wrong numbers in here to confuse you. Sorry, but the basic idea again is temp link deletes 1 link down from where the current is. Okay, so that's the purpose of this first line. So you're deleting the one down from the current, and then you're telling it, okay, then the current next is going to link to the temp link next. So the current next is equal to the next one after it. Okay? I'll draw some more pictures to make this clear. Okay, I think once you have your questions, I'm going to have some
Well, you're
Uh,
going to go through it.
I'm gonna go through it, and I'm gonna probably scan and upload those pictures for you. Okay, so this is the deleting part. Okay, and if again, go through these in steps with a piece of paper, draw these out, and it will make sense. And this one here now is how we're going to insert a link. Okay, so you have a bunch of links. So this is link 6. Right? So link 6 points to link 5, link 5 points to link 3, link 2 points to link 3 points to link 2, link 2 points to link 1, link 1 points back to link 6. Okay? All right, and this picture actually is finally I did it better. So this is what happens to current. So current just moves around these links, and it's actually equal to the link, right? So let's say current is right now at 4. So that means that it has the same exact iData and the same exact next as link 4. Okay, so we're trying to insert, I don't know where we're trying to insert on this thing. So we're trying to insert, let me see. Oh, so insert always inserts after the current link. So link stays the same, circular list, there's a current, there's a count for how many links you have. The constructor sets the count equal to 0, current is equal to null initially, so there's no links. So as soon as you create this thing here in the circ list app, you are going to create the list is equal to a circ list, which is basically just another link. Okay, if you notice this here, or this here has a link and a count. That's what this thing is equal to. Okay, then we're going to insert a new link. Insert the first link. Let's have a look at this thing here. Okay, so first, if you're inserting first link, so this is your insert, right? First, we create a new link, right? New link is equal to new link ID, which is just the value that we're trying to make this equal to. So 10, that's going to be equal to the value of that. So if count is equal to 0, current is equal to that new link, and current next is equal to current. That's what you were asking. So if you have one link, what happens? This. So current is equal to the new link, and current next is equal to itself. So self-referencing. Yes?
Unlike a for loop, why would we want the count to be 0 if we're starting at the first link?
Count, you're checking to see if count is equal to 0. Count equals 0 means there was no links at all. Right? Count equals 0 means there was no links. Okay? So, and if there was no links, what do? Well, this is your link. It's equal to 10, and the link next is actually equal to itself. So next should be equal to L1. Okay, I've kind of broken it down into steps in there, and it shouldn't be. Yeah, I gotta rewrite this too. So at the end, current is equal to link 1, and link 1 current next is equal to current. So that this one right here shouldn't say no, it should say link 1. Right? So link 1 points back to itself. Okay, not null. So that's that. And so basically in this step right here, I show the first line only, but I didn't do the next one. So basically this code right here, current is equal to new link, does do this. But then the next step, current.next is equal to current, is when we change this null to link 1, basically. Okay? All right. So then insert your first link. And we already inserted, I thought we already inserted the first link. So we have the first link. Why am I doing this twice? Oh, there you go. That was at the end. So I guess there was like, I don't know why I did it twice. This is actually inserting the first link. And if you notice, I did it correctly here. So link 1 at the end is equal to current and link 1 are the same. This is basically what this is. Okay? Make sense? Okay. So this is done. And I probably have more explanation than I have to. So that's the first link. Inserting the second link. Okay, so now we're inserting the 20. Remember from before we had this situation. We have current, which is equal to link 1. They're both the same thing basically, and link 1 points to itself, or current, which is the same thing. Now the next thing we're going to do is we're going to go into the else, right? Because this is no longer true. As soon as I insert a new link, I'm going to increase the count right here. So the count increases every time, no matter what. No matter if it's the first link or whatever many links I am inserting, count always increases by 1. So as soon as I was done with the first if, I increased count to 1 now. So which means we're not doing the first if, we're going to do the else. Okay. So the new link next is equal to the current next, right? So let's see if I have that somewhere in there. Where's this thing? New link next is equal to current link is equal to current next. And what was current next equal to? Link 1. So as soon as I say new link next is equal to current next, now the new link points to link 1. Make sense? And again, if it doesn't, pull out a piece of paper and follow the code step by step and try to make sure that it makes sense. Okay? But this is the initial situation. So initially link 1 points to itself, right? Since current is equal to link 1 next is equal to link 1. So when I say new link next is equal to current dot next, I'm saying new link next is equal to link 1. Okay? So that's what I'm saying right here. So now the new link points to the previous link. Okay? And current next is equal to new link. Okay? So then what I have to do is I have to just basically say, okay, well, this current now is equal to the new link, and that's pretty much it. Okay?
Where's the circular link? That was money to itself.
What's that?
How do you update that circular link to come back in?
That was the first link 1 at 1. Okay, right here. So remember that current is equal to link 1 in the beginning. So changing current.next also changes link 1's next. That's one of the tricky things, because you have two objects that are equal to each other. If you change one of these objects, you're also changing the other object. Does that make sense? So as soon as when I say current.next is equal to new link, I am actually, that's the little note I have in here. Remember that current was equal to link 1 in the beginning. So changing current.next also changes link 1.next. So now they're both link 2. So that's how, so initially on the first step, we insert a new link, and we're saying, okay, link 1 is, link 2 links to link 1. Then in this step right here, current.next is equal to new link, is where I'm updating the link 1 to link 2. So now this thing goes back and points to this one. Okay? Current is no longer, current itself is no longer really, well, current is still link 1. Right? So current is actually, the current itself is still equal to link 1, just like we started with in here. I haven't changed that. But what I have changed is, I have changed current.next, right? So current.next, or you could say link 1, they're both pointing to that first one, or link 2. Yes?
So now, when we increment the link, current equals current.next.
Yes.
Goes to the next link.
Yes.
And current is now reset to whatever the next link is.
Yes. Correct. As soon as we do current is equal to current.next, current is being reset to link 2. if I do it again, current is equal to current.next, which is, by the way, the reason we didn't bother changing what current is equal to here is because the way we're going to go through these links is we're going to say current is equal to current.next. So we don't really care about current itself as much as we care about the current.next, what that points to. As soon as you say current is equal to current.next, now current is equal to the one thing after, you don't have to worry about that
So
stuff.
the same as last week, it looks like you're just inserting in the front, right?
Not necessarily.
Just current.
No, I could be inserting anywhere I want.
Well, for this example.
Yes.
What you just did now.
Yes.
And you just kind of inserted in the front.
This would be yes. This is
But
like
You have that circular point.
yeah.
But-
Yes. Yeah. For me, you know, when I was going through this, the heart, you know, and read through these, you know, these little red notes that I put, that's the explanation of what happens here. Okay. I remember I was going through this myself the first time I taught the class, and I got to the point I was like, wait a minute, what's happening here? And then it finally clicked. Okay, hold on. They were both equal to the same object initially. So if I change one of the objects, I'm actually changing what happens to both of them at the same time. Okay, so that's what happens here. And that's your little comment. Let's see, I have probably more. Insert a third link. Okay, so let's do another one. So I'm inserting a third link, right? I don't know where that was. Right, third link is the 30, right? The list insert 30. So let's see what that looks like. Okay. So we're not going to do the first if, we're going to go straight to the else, right? We're inserting a new link. The data for that new link is going to be 30. All right, and this is what the class for the link looks like in case you forget. I like to throw all that stuff in the same place so I can see it. Then we're doing this here. We're telling new link next is equal to current next. Let's have a look at what happens. So this is from before, right? So current next was link 2. Link 2 next was link 1. Link 1 next was link 2. Right? So they're kind of linked like this. Okay. So now we're inserting a new link, and we're saying new link next is equal to current next. So that means that the new link is now pointing to this one. Right? The next of the new link is pointing to this one. Yes? Okay. Then the next thing to do is we have to do current.next is equal to new link. And again, the same comment as before. Remember that current used to be equal to link 1, still from before. We haven't told it to move around or anything. Okay? So it's still equal to link 1. So when I say current.next is equal to new link, I'm updating this link here, link 3, and I'm also updating this right here. Link 1 is link 3. Okay? So basically, link 1 points to link 3, current points to link 3, link 3 points to link 2 points to link 1, and that's your circular list.
Is one still pointing
To 2? No, because it's not a double linked list. So there is no link that points to, well, this one points to 2, sorry. Link 3 points to 2. Right? Link 3 points to link 2.
And one has to point to 3.
And 1 points to link 1. So this one, link 2 points to 1, link 1 points to 3. Yes.
How did you get the 1 to point to 3 again? I know it's this line, line of code. That
How to point to 3. This current.next is equal to new link. Because current, the current was set initially to be equal to link 1, all the way here. Right? That was the initial setup. So this is equal to this. If I change this, I'm changing this. If I change this, I'm changing this. So changing one of these two objects changes the other one. That is why when I go here and I say current.next is equal to new link, the new link is 3, right? I am actually changing this here. So I'm changing link 1.
I thought current pointed to 2 after you inserted the 2.
Mm-mm.
Still pointing
Well,
to
no,
1.
current points to this. Look, this is my current, points to 2, yes, which is the same thing that link 1 pointed to. Notice? So they're both pointing to the same link 2. Yes, you're right.
Yeah.
And then as soon as I get to, I have inserted all the other stuff, so I created this relationship here. I said, I said new link next is equal to current next. That connected the new link to 2, right? And then as soon as I do that, I say current.next is equal to new link. Now I'm changing both this one here, the current points to link 3, and I also changed link 1. Most importantly, link 1 points to this. Okay? And that's it. That's one of the more complicated things to wrap your mind around in data structures, I think, so far that we've done.
It's only 2 lines of code, the second line of code, I'm still,
Yeah.
I can't visualize that second line of code. I think the first line of code is pretty easy to visualize, but, you only have 2 lines of code there, right?
Yeah. Well,
The
that's...
second one, I'm still not.
Yeah, again, it comes down, so the second one thing, if you can't understand it, it comes down to this. Current and link 1 are both the same thing. So when I say current.next, I'm also changing link 1 next. So all I'm saying is new link is the new link. I'm telling both current and link 1 to now point to this new link that I inserted. And that's it. And again, I know that, you know, I can talk about this all day long, but unless you actually get your hands dirty, start doing this, maybe draw some pictures on a piece of paper, it's not going to click. You know, as you can see, I had to draw a whole bunch of stuff in there to try to make it obvious, but, you know, I actually...
No matter how long your link list is.
Yeah. Yeah, it'll work the same way for different arrangements.
The very last link will always point
Yeah.
to the same.
Yes. Right.
Okay, so it's like a side effect.
Yes. Yep. And then remember, the current actually moves around. So you might want to try to see, you know, what happens if current doesn't point to the first link. Maybe what you want to do is tell the current to move down one down, and then see how it changes. That will be something else to try, but I haven't shown that here. Okay. So that is a circular list. Okay. And next week we're gonna do double-ended, double-linked. Double-linked, you can go back and forward between these links. Double-ended, you have 2 pointers for the first and the last, and we're gonna make it a priority queue. That means that you're gonna get your regular linked list, and you're gonna have an insert and order thing going. Okay, and I guess that's kind of it will be kind of easy once you do these inserts here, and once you do the which one was this here? Did we have an insert after a number? Yeah, insert after a value found. So you're gonna have to do a bunch of these. So you will answer your own question by the time you're done with this assignment. How does it actually link at any point? Okay, and that's all I have. So get these written. Let me know if you have any questions. Keep up with this. Come see me in the office if you need to. All that good stuff. Any questions? Okay, I'm going to stop this.